Thank you very much, Adam. Thank you very much, everyone, for having me here in general and for this talk. So I will tell about, as you see, there was a summary published, so probably most of you have an idea what I will talk about. It would be information extraction, so extracting information from text, but from noisy text. So text that is not exactly what it should be. And I mentioned also text output, because I mean text that is produced by systems that we get. Text produced by humans and by systems, because humans also make a lot of mistakes and create noise in their own text. So a bit more on what I mean with noisy text outputs. Noisy text comes from many sources. Common source is results from digitization. That's a very common source of noise. So you might have a picture announcing a talk, and that picture is not straight, it's on the side, and the picture has many other things than text, and you want to extract the text, and here you can see it's not even straight. It has a weird angle, it has a 3D effect, and you would like to know, anyway, if you have a database of pictures, and you're looking for a picture of this talk, I don't know why, but actually you might want to find this, of course, maybe not this very talk, but a lot of people do text search for image collections, and it can be a street name, and the street name is written at the corner of the street in a picture that has a lot of other things in there, and one of them is a street name somewhere accidentally on the side of the picture. Other sources of noise are historical documents, and the older they get, the harder it is. I will mainly talk about historical newspapers, which have the advantage that I worked on in the news project that we talk about. They have the advantage that they are printed, so there's a bit less diversity than in handwritten documents, but still there are a lot of issues that I will cover. So document digitization is for very old documents, like needle-edge manuscripts with characters. Even the characters we can barely read here. Of course, many different scripts. There's also many other alphabets than the Latin alphabets. And also current documents, because we think that everything is digitally born nowadays, but of course, most of the time when you send a document, a letter to your bank or to your insurance company, you might do it by email, and you might do it starting from a computer and do it with a computer, but often in the end of the line or at some point in the process, it is printed and then it goes there, and what do? They scan it. And they have to re-find the text that was actually originally there. So you have digitally born documents that you have to digitize. And banks and insurance, we actually have a lot of collaboration with companies that provide services to insurance companies, because they get so much letters by post that they have to process, that instead of paying someone to open them all, I mean, it used to be like that. Instead of having someone open them and distribute them in the pigeonholes, it's at a scale where they actually, and people work in different offices in different locations. So it's at a scale where they take everything, they scan it whole as a bunch, and they want to process it and separate. They have a PDF file they generate a PDF file of 10,000 pages or even more every day, and they want to segment the PDF file, find to whom it should go, and so they cut the file automatically and they send it to different people. That's one of the many things that, one of the often unexpected applications of analyzing digitized documents. And it's a combination of letters, I mean, sometimes even handwritten letters to complain or to declare some accident, or forms with printed and handwritten, anyway, a lot of forms. I will also talk, so like I said, I will mainly talk about newspapers. The noise can also come from so-called noise. By noise, I want to be very general. I don't want to say dialects are noise, certainly not. But you have a dictionary. It's often for the standard language, and then you have a lot of dialects, and the words don't really fit in the dictionary. And it's not proper to say that it's noise, but it's a similar problem. It's words that you don't have in the dictionary and that you want to understand anyway. It's also the case with different language registers. Sometimes you write spoken language, and then also it's not in the dictionary. And if you want to process many different languages, it's also another challenge at the same time. This is an example of different language register. We can understand it, but we can understand it because we are more and more used to seeing that kind of language. That is a bit mix of phonetics and abbreviations. 8 is a great, but of course, TY means thank you. So it's an abbreviation, it's a common abbreviation, you guess it, but maybe sometimes if you're not used to, I mean, even people in the bilateral conversation might create their own words in their own language, their own dialect. And also, I want to be general about text output. We also get text output from speech recognition. When you talk to Siri or when you talk to whatever other assistant, it will translate, it will not process your speech directly. It will convert it to text and process the text. And that text might be noisy. You probably have experienced it before. If the sentence is a bit complicated, there's some ambiguity, some words are taken from other words, and so on. And we also have worked with music scores, which is another story, but in a way it's similar because you can think that the notes are text and there's many other dimensions, but it's in a way it's a similar problem. And sometimes we even have annotations by the composers, and then it gets even more interesting. So now I will focus on a very specific use case. Like as I mentioned, it's historical newspapers, and it's the context. The word on the context is that it was a Horizon 2020 project dealing with historical newspapers. Actually, a few people from Innsbruck were involved. We worked with the department. So maybe I say everything first. Sorry. It was an almost 4-year project that involved national libraries to provide large collections of newspapers, groups in computer science and groups in humanities or digital humanities to verify and check and guide us and make sure that we just don't improve performance. As computer scientists like to define a task and improve the precision, recall, and F measure and gain 3%, and they are very happy about this. But the problem is that sometimes it's totally useless for the historians. So we had the historians in the loop to make sure that we don't do that, and we make sure that what we do is useful and helps them make new discoveries in the humanities. And in that context, we had 2 groups. I have to mention this. We work mainly with 3 national libraries: National Library of Finland, National Library of Austria, and National Library of France. Guided by the partners of the project, we approached them because we were researchers familiar with the languages of these libraries. And in his work, we had people from Transkribus. Günther Mühlberger was coordinating this, and more computer science side, even though he would argue with that because he's not a computer scientist. And we had people from the Department of Contemporary History with Eva Franzelter, who was actually coordinating the whole. She's here? Oh, she's here. Okay, hello. I didn't know this. Who was coordinating the? So good, I mentioned her. Who was coordinating the activities in digital humanities? So yeah, the motivation for this. I should maybe speed up this part. The motivation to focus on historical newspapers, when I said in general text output, is that newspapers are very interesting for many reasons. First, it's tens of millions of newspaper pages that are digitized, many sources, many languages, many formats. They all have a different layout. They even have a different layout from page to page. They might change completely the layout every 10 years, depending on or less. Whenever they have a new idea for design, or just like we have now. I mean, every once in a while, the newspaper wants to refresh its style and they completely change the layout. Of course, when you analyze newspapers in a span of 200 years, you have lots and lots of those changes. They also change the font and anyway, they change everything. So we have a collection from these 3 main national libraries, and the idea is to be able to give really access to scholars and the general public to these collections of documents. Because in reality, they are accessible, but you cannot read them all. It's of course the classic information overload problem. You cannot read them all. You don't really have tools to access them, and they are stored in different repositories of different libraries. So it's basically in practice, they are all accessible, but in practice, you cannot use them. So the idea was to gather everything, create a methodology, create a proof of concept to support quantitative analysis, but still let the searcher and the humanities researcher in control and guide the qualitative search with this quantitative analysis, and not just tell them what they should do or tell them what they should conclude, but just make suggestions and help them in their own research process. And of course, the challenges are the quality is low. You can see that basically one of the first tasks is to extract the text. I will say a word about it later. But when the document has been folded, you should bear in mind that newspapers are something you're supposed to read frequently. They are published almost every day, every week. They have to be cheap for that reason. And that implies that the paper is not of the best quality always. The ink is not of the best quality always. And they were never meant to be saved. It's something you consume daily. You read it, you throw it. So of course, libraries, I mean, many people realize that this is something very valuable to be stored, but of course the storage was hard and they are often damaged. And simply the fact that it was folded maybe 100 years ago means that you have this mark here and some of the text is lost. You have to guess it. If you zoom in, you will see you have to guess it. And sometimes you have stamps. Sometimes you even have a small part that is ripped off or some coffee stain or anything. I mean, it's newspapers. They were not immediately, now they are stored by default by national libraries and they are stored in good condition and they take a good sample, but for historical documents, we try to collect them and they might come from someone who knows someone who has this issue of 19th of August 1923. We focused on a specific period, 1850, 1950, for the reason that there was a lot of newspapers from 1850, and there's a lot of copyright issues after 1950. So it gives us a nice setting, and it covers the whole century. So many documents. We focused on actually on 4 languages, because Finland has 2 national languages. Actually 5 languages. So we have German, French, Finnish, Swedish, and also some English, because it's of course extremely useful for demonstration. So in reality, we have 5 languages. But the idea is that everything we did was language independent, a proof of concept based on those languages that we can extend to other languages, that we can also extend to other data sources, and we can extend to other research questions, because we wanted to have wanted to provide support and to show that what we do is useful for humanities researchers, humanities scholars. And for that, we had people working mainly on French documents who were interested in literature, from a literature group in France, working on gender issues and the perception of women and the rise of women, or possible rise of women in their presence in newspapers and their perception in newspapers. And it was actually focused on the perception of wearing trousers, which was shocking in the beginning. And they studied the introduction of trousers and their perception in the press, notably. And other phenomena. I mean, I cannot tell everything, sorry. I should speed up. We had the Finnish people who were working on 2 languages, which was interesting, Finnish and Swedish, to see the rise of the national sentiment in a country that is vastly Finnish-speaking, but was dominated by the Swedish-speaking. I mean, most of the money was in the Swedish speakers. So the Finnish sentiment grew more and more, and of course over that period, the independence was declared in 1917. So a lot of interesting things happened. Independence from Russia. Sorry, the Swedish speakers were not really the problem. Anyway, it's a long story. I will not go into details. The colleagues in Innsbruck were working on migration and remigration, and another colleague in Wien was working on media studies, more special media studies, so a more general view on the newspapers. And the idea, sorry again, is here to have many topics, many domains, many research questions. And the idea is that if we can see that this is beneficial to all, then it can probably be generalized to many other questions. So sorry, was a quite long introduction. Back to the topic of extracting information from noisy text outputs. And just, I think it's probably clear to most of you already, but the main challenges of working with newspapers or many digitized documents is that you should never forget that what you get first from the library is an image. It's a picture. So basically, you don't have text. And before you get the text, you might want to know where are the articles. And that is actually not obvious, because you go here, it stops here, or actually it goes on, but at some point it stops. And where do you continue reading? Kind of implied that you go here. There's kind of codes in our brain that make it clear, but that are not so clear for a machine. Here you guess there's only one title here, and it's most likely going here. Historical newspapers are a bit more simple than modern newspapers, because in modern newspapers, more and more, they try to have everything important on page 1, and every half column ends with the rest page 19, the rest page 12, the rest page. That was not the case, luckily, in historical newspapers. It was a bit more sequential. But sometimes you don't really know where the article goes, I mean, unless you read it. So here it's clear. You have a title that goes over 2 columns, so you know that this is the same stuff. Here, actually, well, in this case, we don't know, because there might be a new title. And of course, you have the notion of titles and subtitles that are hard to handle. And here you have the ecos, which is basically short stories. It's like the short news. So you have one paragraph about something, one paragraph about something else, one paragraph about something else. Is this an article? Is this 10 articles? Even that is not clear for a human. So you want to have this. Anyway, you want to extract as much as you can. You also have very simple questions of, is the picture part of this one, or is it part of the next one? Sometimes you have a frame, sometimes you don't have a frame. Every newspaper is different. Every newspaper title is different from the same newspaper title 1 year later. So you need a lot of techniques to do this. And once you have done that, which is hard enough, you can extract the text. Actually, more and more, you do both at the same time, because that's what we have done recently. I will not talk about it now, but extracting the text actually helps you to rebuild the articles, and that's what we have done very recently. But we'll focus on the text now. So once you have the article, you can extract the text. And there are interesting observations to make about this. It's that often there are a lot of errors. Sorry that I took an example in French, but I will focus it on some specific points, and you will see. There are a lot of mistakes. Obviously, 01KE is not a word. This is not what is written. It says on ne, on space ne space. We do not publish the letter of the Kaiser. There was a letter of Kaiser. Many newspapers published it. They explain why they will not. Yeah, so it's obviously not this word. But in reality, if you read this text, and you speak French, this is very clear. You don't even need this word. Something about not publishing a letter, 1 comma apostrophe, that's wrong, because there's a small L, an article. Also here, you can totally read this like this. There's a lot of typos, but you can read it without any difficulties as a human. Your brain is correcting this. You know, maybe you heard of this well-known study of Cambridge University a long time ago. Oh, I don't know, 10 or 15 years ago. It's a psycholinguist. They took a text and they move for every word, they move all the letters randomly, except the first letter and the last letter. And they found out people can read it perfectly. There's very little, it makes it very slightly harder, but not much. But a computer, completely impossible, unless it's well trained. So it's OCR is similar to this. You have a few words that are wrong, it's fine, you can read it. The problem is you have millions of documents and you want to index it, and you will find the documents based on your query that is supposed to find words that are actually not there. So you will miss lots of documents. And that is a huge problem for digital humanities or for all analysis of this kind of collections. There's a logged with mouse here. You want to know what happened with logged with mouse, you will not find it because it's here. It's called logged with move space TTG. That will never respond to a query logged with mouse. So what we did, and this is the main part that we did on extracting information. I will mainly talk. We did many things with events and other things, but I will talk here about what we call named entity recognition and named entity linking. Which is recognizing specific types of entities. from text. First, that is the recognition and the linking I will explain later. So we want to focus on persons, locations, and organizations. There can be lots of entities. You can just define them as you wish. It could be plants. It could be no buildings. But the classical ones, of course, the most demanded ones, I mean, are the persons, the locations, the organizations. And the reason is that the reason why we want to extract these entities is that they are the most queried. We looked at the logs of some digital libraries from national libraries, they're online services. Most of the queries, they are people's names or locations, organizations. That's basically 80% of the queries from the study we did. So the idea is, why do we care about the things humans can read anyway and that will never be queried, like an article? Let's focus on the names, locations. Let's extract them and make sure that they are in the database and make the data findable for the researchers. And that's the whole idea. So we want to find the things in yellow. And not only we want to find the names, we also want to disambiguate. That's a name entity linking. Linking is also called often disambiguation because it consists in linking a mention of a name to a knowledge base, for instance, Wikipedia. So if something says Washington, you want to link it to the city, you want to link it to the state, you want to link it to an actor, Denzel Washington, or you want to link it to a former president, and so on. Also, if it says Kaiser, you want to link it to, it could be many people, but at this time, and when you read an article that is dated and you have a date, and even his name is mentioned later, you want to link it to William II in this case. And the nice thing that we do in this project is that we want to link it everything across languages. So we want to link it to a Wikidata entry, which is unique, whatever the language. So here it says Guillaume II. It will have the same identifier than an English text mentioning William II, and it will have the same identifier than a German text mentioning Wilhelm II. And in this case, Kaiser will also have the same identifier in this document. And that's the idea of that helps us build a larger knowledge base. I will explain later. Then we can build a large knowledge base. It's language independent. It has identifiers for names. And then you can start looking for everything that mentions load with mouse, and you will get the answers in Finnish, French, German, English, Swedish. And then probably you can read half of those languages. Or two, and that's fine, depending on what you want to do. But on the first level, it's fine because you can then do a lot of analysis of sentiment, analysis, polarity, the way opinion is changing, how many mentions are there. You can still do a lot of things in a lot of languages you don't speak. And of course, when you want to go into more details and do qualitative analysis, you need to find speakers, but it still opens the gate to many things that are not possible. So then again, once you have done, the task is to extract information from noisy text outputs. And the information we want to extract is all the people's names, persons' names, and link them to something that identifies them. Of course, the logical question is, can ChatGPT do it? That's the first question everyone asks to anything done with text or image, even nowadays, and many more things to come. So, yeah. First, I mean, this is worth doing, is solved by ChatGPT. And maybe the first stupid idea is to ask ChatGPT, can you do it? And why not? Ask the expert. And it's actually giving but to be honest, it's giving a very fair answer. It says, it is capable to do this, also in historical documents, but the model is ability to train, I will summarize this, its ability to perform in historical documents may not be that strong, and it depends on the quality and the quantity of training data it was exposed to. And as we all know, we have no idea what data training data is exposed to, but mainly web and mainly modern documents, obviously. I mean, we assume, and of course, that's not much historical documents, and therefore it may not perform as well as it would do on more recent text. And that is true. So we decided to, of course, we decided to test what ChatGPT can do, and so we took some benchmarks, well-known benchmarks of named entities annotated manually by humans as a ground truth, and see how well ChatGPT is performing, and see how well our own system is performing. One of them is newspapers, just like I showed you, in several languages. I think it has French, German, English. I'm sure, okay, that's in the first version, in this collection. The other one is a bit even more evil on the ChatGPT. I mean, it's 3 documents, but you can imagine that it's quite hard for ChatGPT. It's actually classical commentary. It's a collection of classical commentary written in English. It's English commentary on the ancient Greek texts. So people have studied ancient Greek, and they write a book. I mean, it's nothing actually surprising. They write a book in English to explain what they infer from the text in Greek. So there's a lot of citations in Greek, and a mix of different alphabets, mix different scripts, and there's names in English and there's names in Greek. So I mean, it's hard for ChatGPT, but it's hard for any other system, of course. It's not just so yeah. We just make it. That's not very important. We just make it produce. We ask ChatGPT to produce the format that is used for evaluation with a prompt. I mean, I'm just sharing the prompt because you should always share the prompt because a lot happens in the prompt, but don't worry too much about this one. I can go back if needed. And what we find out, unsurprisingly, is that while ChatGPT is doing horrible with the combination of English and Greek, and especially it's ancient Greek, so it was even less trained for that. And I said there's names in English and in Greek, but of course there's most of them in Greek because they cite the text because it's a book meant for specialists of ancient Greeks and its characters and its locations. And it's doing a bit better with historical newspapers, but not as good as especially trained models like ours, which I will present now. So you can see better the comparison. So at least a good message before you start any work that you know ChatGPT is not doing so well. Of course, it didn't work that way. We started long before ChatGPT was invented, but we were very happy to find out that we didn't work for nothing. So the big challenge you have, if you want to create a system to do information extraction from noisy text, as always, you want to treat this, I mean, as many things in computer science, you want training data, you want to handle this as a training problem. And the problem is that it's quite hard to find training data, because training data means, so by training data I mean gold standard, something that you know is the truth. Because you have text that is not perfect, there's mistakes, and you need to find where are the names, locations, and organizations in this text with mistakes. So in order to have a ground truth, you need the text. You need to know where are the mentions in the noisy text, but you also need the text corrected and the mention in the text corrected. And you need to align them because sometimes there's many more words or less words, or more characters or less characters. And the problem you have is that most of the time, for the text extraction, there are lots of data sets. The libraries publish the output of the OCR, the text that is produced by the machine, and people fix it. Or they fix it themselves if it's really bad, so that there's something available on the website. And they do it for a very small fraction of their collections. So there's a lot of it. Also in natural language processing, the task of extracting named entities is very old. It's very classic, and there's a lot of data. But the match of having this annotated for text that has noise, that is extremely rare. We created the first collections in that, the one I mentioned before, the height collection. But when we started, there was nothing. So we had the idea to reverse the problem. We don't have what we want. We would need noisy text with the name that is marked, and it doesn't exist. So we inverted the problem. We said, we took the text from modern documents with no noise problems and the name that is marked, and we said, okay, let's put noise there, and we have what we need. We invented what we needed in the first place that doesn't exist. So you take, so of course it's a bit strange because now we train modern documents to learn from historical documents. So we will have a mismatch with the language and language variations, but still we have something good for the noise. So, well, it was something about well, some news about U.S. Navy in Yemen. Obviously, this is not this is more recent. And there's tools. So you write the text. You take the text from some news release in full text. You generate an image. That's very simple. And then you damage the image. Basically, you can have there are lots of tools to do this. There are even text-based tools, but this was kind of mimicking better the aging of the documents. You have the bleed-through effect, so when the ink is spreading a bit further than it should. There's phantom characters that can have many causes. Degradation, and there's also special effect. Actually, this effect is partly from the ink spreading, but it's also from when you scan after the paper is quite thin. So when you scan one page, you actually get some of the backside of the page, and that looks like this. For instance, so anyway, we generate this noise, different levels, very blurry, more or less blurry, more or less from the back, and then you can generate lots of types of noise, lots of levels of noise. And then we run the classic named energy recognition models for modern documents, and we see how well they're affected. I mean, do they do well? Maybe everything is fine, and nobody needs to do anything else than use the modern tools. So there's a step of alignment. I mentioned it. I think there's no need to go into details, but of course the text. When there's OCR errors, there's more text or less text, and you still need to adjust the two versions. And here you can see our results. This line is the quality number of characters. So it's basically the quality of the input text. Percentage of characters that are not where they should be, are not what they should be in the correction. It's the number of words that are affected. Of course, it's higher because when you need only one character you have less words and you just need one character wrong to make one word wrong. So the percentage of words that are wrong is always higher than the number of characters that are wrong. Not always. In theory, not always, but in practice, always. So here you have the different levels. Quality of text. Basically, this measures the quality of text with different degradation, level 1, level 2, character degraded, blurring, and so on. And this gives you different qualities of text. And here we run standard energy recognition tools for modern documents, and you can see the impact that it has, how well they perform compared to state of the art with no noise, which is here, the clean data. Sorry, I should have mentioned this first. This is clean. This is the normal performance they have, and thus amateur performance is damaged by the quality of text. So it's always losing, and level 0 is before we do that degradation. It's, we generate an image. First we have the initial text, then we generate an image, we do the OCR without adding any noise. We already lost something. And then we put noise, that's mimicking the aging of the document. And then you lose a lot more. So we use that, then of course you can make a curve to see what is the impact of OCR noise on the energy recognition, and you can see it has a bit of impact and suddenly it becomes impossible. So it already kind of an interesting result because people can see that if the OCR quality is this level, maybe don't even bother, don't even try to get named entities because it will be very bad. And then with all that data, everything we learned, everything we trained, well, we could train a model. Once we had this data set and we knew that it's important to do something dedicated to historical documents or to noisy text, we made, of course, many experiments, and we found a good system, very simple idea by a former postdoc in the project. a very simple idea, which is, I mean, now I was trying to be understandable by everyone in the disc, like computer science and not computer science. Here I will have to go slightly more detail. I will not say more, but we use several layers of transformers, because the idea is that when you use a layer of transformer in a deep learning model, it's looking at context. The idea is that it's looking at context. And if you had several layers of transformer, it's looking at more context. And why do you want to look at more context? Because often the context is a bit less reliable when you have a noise. When the text is clean, you know that the word before is a good predictor of the word after. And if you look for 2-3 words before, and that's actually what language models are doing, that's what generative AI is doing. If you give me 10 words, I can tell you what is the 11th word, most likely. But in this case, I mean, that's what the generative AI is doing. It's generating the most likely sentence. It starts a sentence, and then it's producing what is most likely to happen next. And the problem is that here you cannot really learn from the context, because the context is not reliable. You know that maybe if you have word error rate 20%, it means every 5th word is wrong. So you cannot build on that kind of context. And the idea is but still, you still have more right than wrong. So if you extend the context, you somehow give more support to your tool. Then again, it's only assumption, because it's deep learning, so we don't really know what happens in the neurons. But that is a logical assumption, and that works very well. Because it won't, yeah, of course it works for every language. It's just deep learning. It's not, we don't do anything specific to languages, so we won't participate to a benchmark, and we have all the best scores in every language with a simple idea. And then we improved it more a few years later by taking more temporal entities into account, because when you analyze text, you always know when time it was published, and you can adjust to the language. It's the same idea, but then you add more context from the time of publication. And anyway, oh, I don't have the same here anymore. It doesn't matter. And this also, then we won the next round of the competition in all the languages. And for the new project, I can give you some resources. Everything is open science. If someone is interested, it's easy to find, and we even have a platform that you can check, where you can browse. And I mean, the simple applications of this is that you get the name entity recognition, you get the name entity linking, so you can browse instead of searching for typing names. You can actually access the names and get all the documents with that name. You can get them in all languages. You can filter the different languages. You can extract the data set that you can analyze with your own tools outside, and so on. And of course, newspapers are interesting for many things. So we have educational material, and code is shared. Anyway. So in summary, the main message here is that the LLMs with only 2 L's are still below, maybe with 3 L's they will be better. The LLMs, large language models, are still below the state of the art when it comes to digitized documents. Well, there are many reasons why we should not fear them too much when it comes to historical documents, simply because there is not a strong incentive to analyze historical documents. And we also have the advantage of, I mean, we can better explain what we do with our system, even though it's deep learning. It's not based on a large model that was trained on we don't know what, and that is producing answers that may or not be right, but we don't know why. So that is more satisfactory for most users, even if one day it's not performing as well. It has still this typical strengths. Yeah, so and that highlights the needs to have approaches that can work just with the raw material. Like I mentioned, you don't always have well, you often don't have everything you would need to train a large language model. And what we learned, that transformer layers can compensate the loss of information due to the noise, because they look a bit further and they try to, well, they get more background by looking a bit further than the typical Not from transformers, but typically in computational linguistics for quite long, it was said that to find, for instance, collocations or to understand the meaning of a word, you have to look at the 5 words before and the 5 words after. Of course, this is strongly biased for English. I'm sure it's not true for other languages. But it shows that if you look further, you can actually kind of counter the noise impact. Anyway, yeah. And I mentioned now I was only explaining actually named entity recognition, but we did similar works for named entity linking. So what I said is connecting the person to its own identifier across languages. And we did this also for events. Find that some earthquake happened somewhere, and it's the same earthquake that is mentioned in another newspaper in another language. And sentiment analysis. So we also added what we call I'm looking at, I forgot the term, but the perception of every time a named entity is mentioned, how is it perceived? Is it mentioned in a positive or a negative light in that context? Which is very subjective, very hard to point, even for a human. When you read an article, is it really negative, or do I feel like it's negative? But if you look, the idea is not to look at every specific point, is to look at the trends. You have 200 years, you have millions of documents, and this still gives interesting trends. And you can see that some countries and some characters are more appreciated in some press than in other press, and in some countries than in other countries. And some people don't exist in some countries. But that is more the work of the historians. But these tools provide this kind of things. And that concludes my talk. I hope made sense.